Okay, so this next chapter is called Fundamental Design Principles in Classical Architecture. I'm sure if I'd have my drawing table available if I need to draw some sketches, but I'm sure you've probably seen a lot of these when you've taken fundamental design classes in any sort of art class or architecture class. You've probably seen these before. There's a list that we're going to talk about, ranging from just some very basic design attributes. I teach this in classical architecture and modern architecture. We're going to see some really wonderful projects. I have a mixture of projects between Palladio, Edwin Lutyens, and John Soane. And so some of these are a mixture of symmetry, centering, local centering. What is that? What does hierarchy mean? And strategy of line. Before I continue, I do want to say that, I think a lot of architects, philosophers consider architecture, I think, to be, if not the highest art form: space, form, light, and order. And the modern architect, Le Corbusier, coined the term, without a plan, you have a lack of order. We're going to be looking at a lot of floor plans as kind of the generator of all things. And then at the end of the lecture, I can go back and we can pause this and can write this in your notebook. Hopefully, you guys are taking notes and sketches while I'm lecturing as well too. Okay, so I think I'm sorry. Okay, let's look at the first one, axial condition. I think most of you guys have seen that classical architecture is primarily symmetrical and associated around a center, in other words, a central axis. On the left, we can see what's called a minor and a major axis. The major axis is the large center line that goes through and, of course, divides side A to side B based on symmetry. What we're looking at here is an axial condition based on what's called a slot of space. At the end of it is a receiver. It's a very traditional classical way of articulating a spatial zone in classical architecture. It's a very common typology about how classical architecture is organized. The same thing with just this kind of ideal plan bill that I quickly drew to show that plans in classical architecture are symmetrical with a few exceptions, and there is an emphatic center about things. Let's take a look about the center. This is the Altitude Museum by Carl Friedrich. So we've seen this in our lecture before, but obviously classical architectural plans are for the most part symmetrical. This metaphor to the center of the human body is the large cylindrical space that is at the center. We're going to talk about, symmetry versus asymmetry, Palladio's Villa Rotunda, the ancient Roman baths, and some of Carl Friedrich Schinkel's asymmetrical work. Let's start with Villa Rotunda. I think we've seen this many times in the class. It's emphatically symmetrical. By that, I mean every sort of the major and minor axes are exactly the same, with this very little variation. The only time it varies the symmetry is the different sculptural pieces and figures that are on the pediments. But again, we see a very typical classical floor plan, a very simple organization of pretty much the east, north, south, east, and west axis are exactly the same. Here's a coaxonometric showing the three-dimensional form. Of course, it's pretty much a mixture of Greek and Roman. Palladio was considered a Renaissance architect based on the fact that he's actually borrowing the classical Greek temple front and superimposing it in kind of an ancient Roman spherical dome space. Here's the, pretty much the facades are all the same. The only time it breaks is possibly the chimney, and the symmetry breaks with some of the sculptures that are around each one of the pediments. Of course, it is a great Ionic pediment front superimposed on a Roman dome. A very typical classical motif. Palladio was considered somewhat of a modernist because not every surface is decorated with the classical orders. It's beautiful to see the simple, smooth plasterwork unadorned, and then the only time you see the classical details are, of course, the cornice, the Frisian tablature, and of course, those magnificent Ionic columns. Yeah, again, these are just some typical symmetrical floor plans. You can see the basalt column are symmetrical about the main axis at the center. And of course, the short axis has a different relationship. In other words, not all facades are exactly the same in this, but for the most part, this plan is symmetrical, organized about a central axis. Let's take a look at times where classical architecture breaks the symmetry of things. This is, of course, the famous Acropolis plan, the the Pantheon, and I'm sorry, that's supposed to be the Parthenon. I misspelled that. Oh my goodness. So let me get back for a minute. Let me back up for just a second. It's so easy to get these two buildings, the Parthenon and the Pantheon, confused. In other words, the Parthenon and the Erechtheum is that there's really two relationships on this site. Of course, the Parthenon is the symmetrical plan about a central axis. And then what's strange is that the Erechtheum, the smaller temple, is emphatically asymmetrical. There's really no central axis or main center line about the organization of things. It's kind of a regular shaped building. Of course, it is the one that has the famous caryatids of the columnar order. So on that site, we see really two different buildings. We see the Parthenon and, of course, the Erechtheum there on the site as these two really symbolic temples. It's just a little bit unusual to have classical architecture as asymmetrical. We'll see asymmetry later in the lecture. Of course, this is one of the temples that has the actual Parthenon has only the Doric order, but of course the Erechtheum has all the classical orders established: Doric, Ionic, and Corinthian, the three basic orders before the Renaissance. So this is kind of an articulated little jewel box. So let's look at some of classical asymmetrical composition. I like to show Carl Schinkel's neoclassical architecture. This is a country house. It's called Charlottenhof. I think it's technically called the Roman Baths. It's a large complex of building, but it's a classical building, but it's not symmetrical at all. We can see an asymmetrical composition of pediments and towers. If you can see the floor plan, there's parts of the plan that does have what's called local symmetry, and then of course little outbuildings are asymmetrical compositions. There's kind of an irregular dialogue of the Roman arches on the right, and of course, the Greek square columns on the left. It's interesting that when classical buildings are in cities, they are emphatically symmetrical and formal, but in country houses, they're a little bit more informal, rugged, and asymmetrical. It's an interesting visual and formal topology. They break between cities and countries. But there are parts where the buildings are emphatically symmetrical. The large bathtub around a central hall, which is quite a break from the exterior asymmetry. Here's another plan of Carl Friedrich Schinkel's plan for a country house. There are parts of the plan where they are symmetrical about a central axis, but then obviously the entire building is not the same on both sides of a central axis or a center line. But it's still classical because we're still building in traditional heavy load-bearing masonry walls. And of course, there are columns that define porticos and central courtyards. So we get to Edwin Lutyens' country houses roughly between 1890 and 1920, is that this is a wonderful house that's called Tigbourne Court in Surrey, England. Now these houses are, of course, Edwin Lutyens was incredibly skilled and talented at designing classical buildings, which means classical plans are based on an emphatic center line. When we got into the country, his houses are very irregular. They're not the same about a central axis. There are parts, if you look at the plan, where there is an emphatic center. The vessel and the porch are aligned with the central axis. And of course, the two motor courts, the elliptical circular parts on the left and right side of the central axis are, of course, established certain symmetry. But of course, the parts where we see flower room and hall, the garden facade is not symmetrical, it's asymmetrical. There's a wonderful sundial above the front entrance. But of course, the public side where the car disperses from the street, of course, is emphatically symmetrical. Again, this is another project he did. It's interesting that his early country houses are designed to look undesigned. What does undesigned mean? That means that, this plan is a kind of irregular asymmetrical composition, not bound by symmetry or formal compositional rules we saw earlier. It's interesting that, this house looks like it's built in the 1600s, but really this is probably built in the early 1900s. And of course, you can't possibly do a brick masonry wall with a large span. If you look at the panel above the large rows of leaded glass window, you can't structurally do that unless there's steel. So there's a clue that this was built after the Industrial Revolution, despite the span of these large leaded glass openings. Of course, Lutyens is using steel behind the wall, but it still is an asymmetrical, and of course, a beautiful oversized chimney. large chimneys, more chimneys were considered a status symbol in the English countryside. We had, enough money to build fireplaces where they were considered very wealthy. So we talk about local symmetry. What I'm calling is the curved exedras about a central line. You look at the curve, and Lizzie, can you see my cursor on the screen? I think you can.
Yes, we can see it.
In other words, there's parts of the building where it is exactly emphatically symmetrical about the curved exedra, the large convex form, which is the courtyard, centered about the two bedroom wings, which are convex curves on the facade. And of course, but the building itself is not exactly symmetrical. So there are parts, it's a very common classical basic design skill to have parts of it symmetrical and the other parts of the wings are not exactly the same on both sides. This is, of course, Nashdom House. It's a really beautiful project. The center panel is, of course, the entry arch with the curved exedras on the left and right side with multiple layers of triple hung windows on either side of the facade to let natural light in here. Here's another, I think this might be, I can't remember which project this Lutyens plan is, but of course there is a local symmetry established by the central line of the exterior pavilion. The main entrance hall is symmetrical about the two diagonal wings. Then of course the outdoor pavilion, I think this might be called Papillon Hall by Lutyens. I think I'm remembering that. But of course, the house is not exactly the same about the central axis. So another term is called hierarchy. What does hierarchy mean in architecture and classical architecture, arts, pretty much any art form? Hierarchy means a level of importance. So we were looking at, these are several plans from Palladio's Quattro Libri, in other words, his manifesto of the 4 books in architecture, which we're looking at. We see a plan of hierarchy. We can see that the large central entry space here, some of them are rectilinear, some of them are curved like the Villa Rotunda. In other words, the main central hall is the largest space. The auxiliary spaces are secondary and smaller. Pretty much each plan has a level of importance by the different sizes of the spaces. And this is very important for any plan, any architecture, any style, modern and primarily classical architecture. Let's look what happens when you have a plan with no hierarchy. Wow, all the spaces are exactly the same size. The doors and windows are all the same size. It's a plan of complete banality, but functionally, if you were to do what's called projecting yourself in plan, which means you have to imagine, walking through, let's take, this is the supposed front door. So if I'm walking through this plan and I'm walking through here, there's really no space to acclimate yourself into going to. As soon as you walk through these, you want to get out and get into a larger space. So the problem when you have no hierarchy is that you have pretty much a lack of different sizes. So the beauty of Palladio's plans in any sort of plan or any architect is that the size of the spaces is of course very important in hierarchy. We talk about hierarchy in plan and sections that of course we see the main entry volume of space in Palladio's Villa Rotunda is of course the tallest, the most celebrated space, and the other spaces around that are shorter and smaller. And incidentally, classical architecture in Palladio's world and most of classical architecture really does not celebrate the staircase. So the staircase is carved behind these post-shade sections in the transition from the rectilinear parts and of course the curved parts. You would never see, rarely see a grand staircase in Palladio's early builds. It's interesting that he disguises the circulation and of course the post-shade. This is Alty's plan of the museum. What I'm showing you is that the circulation are these little circular parts that are post-shade out of the thick wall transition between, of course, the layers of circulation and, of course, the dome. So in these early plans in the Renaissance in 1500s, the stairs and circulation is not celebrated. They're tucked behind the walls. You really don't see a grand staircase in any of these. Again, the circulation, the plans of the Basilica are very symmetrical. So another one is called strategy of line, specifically in Hadrian's. What does that mean? A strategy of line We've seen this before in our early geometry lecture. Apollodorus, primarily Hadrian's architect in the 1st century AD, establishes a strategy line. This is, of course, a large model. The Hadrian Villa is now a large public museum. There's an entire model, the entire complex. This is Hadrian's enormous private villa, but of course, mostly occupied by servants and a lot of, lay people, gardeners, dignitaries live there. But this is just an enormous complex of a myriad of different buildings, ranging from public spaces to private villas to museums themselves. Again, this is another picture of the large fork we're going to see in the plan. So, and of course, here's the famous Canobus that everyone visits and gets a postcard as a souvenir. Here's a plan of the famous Canopus that we see in this three-dimensional photograph. But the strategy of line determines center lines, not necessarily proportional relationships, but of course the layout of all these very complex individual buildings. What I was showing in my lecture last week is that the diagonal, if you look at what's called the large public space, which is the main entry into Hadrian's Villa, is that the large public space, the diagonals determine the placement of some of these rotated fields. What I was saying earlier is that the rotation is primarily depending on the layout of the topography. This is situated in a hillside in Tivoli, Italy, several miles outside of Rome. But of course, the topography determines the orientation and some of the diagonals on the site plan. And what Apollodorus is establishing is a kind of an ordering language of the strategy of each one of these lines. What I was showing you earlier is that if you look at the diagonal of the main courtyard, is that the corner of this projects up and establishes the corner of the smaller cortile, which of course is the transition between the Maritime Museum, which you see in the round temple, which is a transition piece between these two large outdoor spaces. If you look at the 90-degree terminus, of course, establishes another center line between the center of these little outbuildings that surround the Maritime Museum, of course, which is between the library corridor and the main corridor. You're looking at is a very careful, disciplined order of the center of things. And why would someone do this? Probably because for pragmatic reasons, it's very, we didn't have, hundreds of plans and drawings and blueprints available for surveyors. This is probably a map to convey to surveyors how to lay out these really unrelated things in geometry and how you would set up the site plan in person. And of course, the main canopus here is emphatically centered about the center of this large cortile of the outdoor courtyard. Of course, the center of the main thick wall zone is, of course, centered and aligned with the terminus of the alignment of the canopus. So let's look at this relationship. Somebody was asking me last week, are there clues to where these centers and these axes actually occur on the facades? Well, clearly we can see that the diagonals on the landscape terminate to one center in the main wall, the main corridor, then of course establishes a center in the opposite facade as this Serlian arch, which of course houses the curvy corridor between the main pavilion that links the canopus axis to the main corridor. So then you can see that Apollodorus is establishing the center of things based on a very large kind of urban scale. So strategy line is a very clear way of ordering parts together. If you look at the center, the Noli map of Rome, the obelisks established a certain strategy of line because, of course, the obelisks were established to orient yourself in the city during Pope Sixtus V's plan of Rome. Again, here's a narrow view of all these incredibly complex convex and concave forms which articulate the geometry of these very large, seemingly unrelated parts which are oriented about a strategy of alignment. Oh, sorry. So our next subject, sorry, my slides are overlapping each other. It's called spatial layering. What we've seen layering as literal layers on facades. Oh, let me get back to that. I'm sorry. This one is out of order. So when we look at literal layers, we can see the pilasters are the physical columns that articulate the facade. Those are literal layers applied onto a wall. We talk about spatial layering, we're talking about something very different. Again, let's go back to Carl Friedrich Schinkel's Alpine Museum plan. It's a little bit different than, of course, the model for this plan, of course, is the Pantheon in Rome, which of course we see as there's only really one layer of space. The front is that the large portico that transitions from the exterior piazza into the central spherical nave, and of course, the Pantheon. But we look at Schinkel's plan, it's quite a bit different. He superimposes the large plan of the Pantheon into a large field of circulation, a zone of space. In other words, the corridors articulate the zone of space between the two courtyards. It's not just the round drum exposed to the air. There is a zone of space, of spatial layering around the large dome to establish a circulatory zone and a transition layer between the two courtyard spaces inside the main central dome, which of course is the sculpture gallery in the museum itself. It looks like in terms of spatial layering, there are literal spatial layers as independent blocks. So this is kind of a diagram of the plan of the central part in Carl Schinkel's Alten Museum, as that looks like the spatial dome is separated by these circulatory zones of space, light, and air. A very clever way of transitioning between the main central space and, of course, the circulation zone, a really beautiful corridor, particularly with light coming in through hallways. Of course, we see that the stairs are not celebrated. They are tucked in between what's called the pochette, the carved out elements between the two geometrical fields, the linear field and the cylindrical field. The same relation with the large central staircase at the entry. So there is a spatial layer of outdoor entry space that transitions from the large space in Berlin, of course, passed by the stairs and, of course, into the main central nave. You know, we've seen this one before. This is on Jacques Gabriel's Place de la Concorde, a large section of the building that faces Place de la Concorde in Paris, is that there is a large circulatory layer as the main facade of circulation, light, and air. You can walk as a pedestrian covered by the building without actually entering the private spaces of this large public building. So next we're going to see an absolutely fantastic combination of all the stuff we talked about in basic design in the first part of this. The first part of the lecture is that we're going to look at John Soane's museum, a very famous spatial address, 13 Lincolns Inn Fields in London. Architecturally, it is, and spatially, it is a play on visual complexities through slots, axial conditions, primarily spatial layering, a celebration of all the basic design elements we've talked about earlier in the lecture. Here's the front of it. I'm sure you've seen and visited this. The facade kind of boasts a very unusual, of course it is classical because it's load-bearing and does have classical motifs. Here's the front of it. What John Soane did is he took this existing brick London townhouse row house and superimposed a new facade layer on top of the existing one. It's interesting that it's almost kind of a modern approach to the facades because we're not seeing the classical orders literally applied into the place. It's something very what's called considered modern at the time. The striations in the facades indicate an entablature and columns without literally making it Doric, classical, and Corinthian. And look how large the windows are. This is probably the mid to late 1700s. You know, classical, the windows are very large, opening of glass with very thin mullions. The mullions, of course, the steel and wooden bars that divide the glass. What's considered kind of an early modern because the only classical order is, of course, the caryatids that are terminuses at each one of the pavilions on the left and the right side of the entry. Here's a famous, I'm sure you've seen the famous breakfast room, which we'll talk about in more detail a little bit later in the lecture. We've seen the main salon, the living room, of course, which is on the second floor of the Piano Nobile. But let's talk about the plan orientation. It's a very complex series of spaces, very difficult to decipher in just about 30 minutes. But I kind of broken down this plan into two parts, major and minor axes, and of course, spatial layering. Let's take a look at the plan dynamic with the centers. The center line, of course, determines the emphatic center and parts of it. The main salon to the bottom right and the front library are, of course, oriented about the central axis. There's a major axis to the center of the living room, salon, and of course, library in the front. But look at what he does with the facade. It's an independent layer pulled back from the existing shell of the building. So in either event, you can see perpendicularly through the facade and of course out from the main living. Rarely in John Stone's work do you see the front facade as the main layer of space. There's actually an independent layer which adds a transition layer from street and courtyard into the main body of the building. Of course, these other square pavilions are the main dining room and studio spaces in the museum itself. So the minor axes are these transition zones, which I'm calling spatial layers. If you see the perpendicular line is these incredible little, tiny little linear slots between the main spaces. So rarely would you walk from one space to another directly. There's an indirect path you pass through the thick wall here. There is a beautiful layer of space, which I'll show you in just a minute, between the thick wall zone, between the living space and the library. You know, this is a very complex classical plan, which we've seen in Lutyens' work earlier. And of course, Schickel's are much more complex and elaborate. I like to show this one because this is such a wonderful mixture and playful language of the classical early sort of typology. And pretty much, if you carefully look at this plan, there are minor and major and minor axes going everywhere. There is a transition layer between the main space. If you look at the next slide, I've highlighted the transition zones that are separated by the large semi-public spaces, the dining room, the breakfast room, the studio space, the gallery, and of course, the living spaces at the front. It says layers around the space are articulated as slots. There is a zone of space, programmatic space. These are circulation zones without actually entering the primary spaces. Of course, then these are zones of circulation and light. Pretty much in each one of these linear slots, there's a beautiful skylight that articulates the main spaces from the auxiliary corridors around that. So thick walls, we can see that in post-shade, it's carved out of frames that indicate thick walls. You can see that the plan of each one of these has its own really thick layer of course, the walls are very heavy because this is the library masonry, but stone articulates these individual thick walls as these zones of space and light. Again, here's the same diagram that John Stone has investigated in this plan, is that the spatial layering is treated as these individual block layers of space. Here's some sections showing the vertical zones. Again, what I'm showing you is here is a photograph of what the actual space looks like now. Stone was an incredible collector of all of these ancient artifacts. It's almost a little bit difficult to decipher the architectural space with all the stuff in it. It is incredible. Rarely have I seen a photograph or drawing without all the fragments in it. But you can see that each one of the cylindrical main primary spaces are articulated by the zones of slots of space and light around that. Here is a perspective view of this section through the main sort of central arch, and I think this is just considered the gallery space. Here is a longitudinal section through the entire gallery. You can see that the primary spaces are articulated by these thin little zones of circulation and light. So you can clearly see the layer of space in the section. The roofscape is just incredible with all these intriguing little skies that project the roof plane. Stretching at the bottom layer of the ground floor, the basement is a series of sarcophagi, which has mostly ancient crypts, which are really interesting and somewhat creepy to visit in person. There's very little natural light coming into the basement, but that's part of the intention. Let's take a look at some of the details. This is a view of some of the slots I showed earlier in plan. That photograph you just saw was really probably either this layer or this layer. It's a wonderful visual complexity to walk through there and see these different layers. Here's a wonderful watercolor showing some of the corridors between each one of the spaces. And let's take a look at the ceiling. He does these wonderful imaginative skylights, which are above each one of these zones, these layers of space. Here is the main skylight. Of course, there are some engravings on the skylight panels. You know, and look at the way that Stone has his own classical language of the way that the ceiling is articulated with the openings. He's really not using Doric, Ionic, and Corinthian in the classical language. He's kind of creating his own neoclassical, very original language of detailing architecture. So here is the main salon. We see the fireplace. A very unusual treatment of structural, of course, these are not structural artists. What he's doing is he's making a thick wall zone, but he's denying thick wall by having these thin little layers, which indicates a thick wall zone. But then instead of having the mass of the wall continue down the ground, you see these thin little bars, or to these little brass columns. So he's articulating the individual spaces by these thin layers of wooden panels. Normally a classical architect would show this is a heavy post-shade low-bearing masonry wall, but Sohn is kind of inverting that and showing you can still articulate space with these thin, really decorative layers. Very elegant to do too. This is probably about 50 years after they discovered the ruins of Pompeii. So his interior language is heavily based on the simplicity and the elegant language of the Pompeian ruins established in, 79 AD, were discovered in the 1700s. So the thinness and the thin layers is probably based on discovering the ancient ruins of Pompeii, which you clearly see the Pompeian language in each one of these interiors. But let's take a look at the detail of the wall. It's really interesting the way he articulates the space by these spatial layers. There's all these really intriguing, unexpected visual zones between the wall plane and the main space. So there again, we see the plan of the major and minor axes, which are completely filled around the entire plan of this. So in the breakfast room, we can see the layer of space is circulation, the doors. Instead of directly entering into the space, there are these secondary zones, which of course, these are probably servant zones between the kitchen and this is the famous breakfast room. But it is some very intriguing visual complexity by having convex mirrors, kind of to blur the distinction of the corners inside the actual building. Here's a wonderful detail of the skylights. And again, here's a cross section of the main breakfast room we just saw. You can see that the skylights are very indetectable from the interior space, but he makes these visual complexities. Is the hallway outside or inside? It's hard to tell until you walk through there and can see that the skylight projects above the sky in these cross sections. Here's an interior facade detail of what Sohn is doing with the geometry. We talk about geometry and architecture. What looks like kind of a mixed match of different curves is a very specific way of organizing the center of the curves. If you look at this diagram, is that what looks like an arbitrarily related series of curves, that there's a specific order to the way these curves are designed. Is that the semicircular arch is actually a true circle segmented in half. Then, of course, the segmental curve shares the same center as the two larger curves on either side of that. So when looking at this, as a visitor that doesn't know anything about architecture, they think that the curves look pretty and really neat. But of course, there is a geometrical language about the way these things are carefully designed and positioned. So if you were to go back and analyze the way the radar, the radiuses are established, there is a specific language of order based on the center lines, of course, the different curves. It's wonderful, but a little bit frustrated to appreciate the laying. There's so many artifacts in this place. This is his home and school. The school is upstairs and a third layer with even more fragments and details and just incredible drawings. It's a wonderful museum to go and visit. Here's kind of an opposite. Here's literal layers, and one of his facades, the Pitzhanger Manor, is that the classical order is a literal layer of columns articulated on the facade. These are just the last part of my images. I'm just going to go back to the first part of the slides, just some terminology that's really important. And again, in 30 minutes, this is just a very beginning introduction to basic design fundamental principles. Let me go back to the first slide. Yeah, an axial condition, symmetry versus asymmetry, centering, local centering, hierarchy, strategy of line, thick walls, and layering. This is very, very beginning important relationships that every student and novice or aficionado architecture really needs to know. And we have about 20 minutes. I can you can turn your mic off and ask questions, or I can stop by some of the slides to kind of go over some things. Lindsay, you can chime in on some questions. I think I'm not able to see the chat.
Oh, yes. I wrote in the chat box that people can type questions. I don't have any that have come in yet, but as soon as they do, I will let you know.
Well, I'd like you to write these in your notes, the list of just basic design elements for any beginner, for any architect. Well, you can imagine if you look at the Villa Rotunda, how anticlimactic it would be to walk through this space and not have the dome project up like that. If everything was the same ceiling height, it would be difficult to experience this as the main space, of course, the building. And let me know if I need to stop at any of the slides.
And thanks, Jim. Yeah, there's no questions. I don't think
Wow.
from anyone right now. I know you just
That
take
must
all
mean
questions away.
everyone understands everything I talked about. Well, I think probably some of the people in here probably have already learned this in their design education, which that's good.
I do have one question for you now. You had mentioned that the staircase was not a feature in classical architecture. When did it appear as an embellished feature?
That's interesting. When I mention that, I'm really primarily talking about Palladian's architecture because the spaces are important, not the circulation. I'm going to say it's probably the neoclassical phase where you have a grand staircase, primarily neoclassical architecture in large antebellum southern states in America, where the bride or the debutante parties had this enormous staircase to celebrate the sense of arrival. I'm not an expert on that. I'm just going to say probably neoclassical, where they did celebrate, because even in Lutyens' plan in 1920, the staircase is still hidden behind the wall. That's a good question. I'm going to guess probably, I'm sure there have been, celebrated staircases throughout history, but primarily I think neoclassical architecture, where they pulled the circulation out and made that a beautiful kind of event in a main space. I'm going to say that's probably an American architectural invention. I was going to stop on this one for a minute, and Lindsay, you can tell me if there's other questions. I was remodeling a house a long time ago, and the house was built in the 20s. They kept adding on rooms and rooms and years for years. The first time I walked this house, I was working for the wonderful Ralph Dusing architect, and he was very classically oriented. And I walked this house, I kept thinking, where do I walk to? I kept walking through each one of the rooms, were all the same size. It was very anticlimactic to walk through and have every single space. But so the reason they commissioned us is because they wanted a great room. And I thought, well, of course, because you're walking through, there really is no stopping point. It's all just walking from one same size space to another. There's really no space to kind of stop and enjoy the architecture. So when we look at Palladio's plans, there's an emphatic hierarchical relationship and plan in, of course, and especially Lutyens' plan, and of course in the section in Palladio's work. So.
We had two comments that were following the stair discussion, and Tim had said French neoclassical architecture as a addition, I think, to the when it appeared as an embellished feature. And then Eric had said that the stair at the Michelangelo Laurentian Library is amazing. So those are some two comments on the stairs.
Yeah, if you have, I was going to Google that, because that is an interesting, the staircase in Michelangelo's Laurentian Library. Yeah, that is a celebrated stair. And what I was mentioning is, can you see my Google search?
Okay. Sorry, what? Oops, now you've gone off.
Share my screen again. Can you see the Google search?
Yes.
So yeah, that's an excellent comment, because I think Robert Venturi discusses this in Complexity and Contradiction. It's strange that the entire main space, the stairs are way too large. Well, his argument is way too large for a relatively small square space, but in plan, it's really designed for the scale of the entire library. But yeah, and for years, I can never really figure out why the stairs are really wonderful. It's circulation and seating, is that you can sit on the treads. That's a really, I'm glad you mentioned that. And of course, we see Versailles, which has incredible celebrated stairs, but it's a really strange volume of space to have the entire space raised with this enormous staircase. Let me see if I can get a plan, because there's almost not enough room in front of the first riser. Well, look at that. Normally in classical architecture, you would have the landing in front would be the same width as the stair. But Michelangelo at this time is a mannerist. He's really kind of inverting things and sort of poking fun at classical architecture. So that's a very good comment. Here's a section. But look at the stair in relation to the main library. It's proportioned for the entire building, but not for the main entry space. That's interesting. But of course, architecture is full of wonderful contradictions. But of course, Michelangelo can get away with that. But mostly in Palladio's and Inigo Jones's work is that the mid-Renaissance architects did not celebrate the stairs of circulation. So you really wouldn't see a grand staircase in primarily Palladio's work.
No more questions for now, but if anybody else has any they'd like to add, please feel free.
Okay. And I'll share the slides again. I'm going to show this for just a minute. You know, probably the largest stair that I'm thinking about is probably the Scala Regia in Rome at the Vatican, but it's still, hold on a minute. Can you guys see this floor plan for a minute?
Yes, it's showing the Wikipedia screen.
Yeah, I mean, even this staircase is tucked in its own special zone. It's not just exposed out into the central nave of the church, but still, that's one heck of a staircase, is it not? Yeah. That is the definition of a celebrated stair. Yeah. Then, of course, we see the double helix stair that Leonardo da Vinci designed in, I think, Chateau Chambord. Yeah, so you guys can't possibly believe everything I tell you. Hold on, my internet is getting slow. Yeah, now this stair is more than just a circulation zone. It's structural and spatial as well, too. Okay, well, our next lecture next Tuesday is paradigmatic buildings through, if I pronounce that correctly, throughout history. Then the next one is contemporary built environments. And then that'll end our chapter in literature and theory of classical architecture. Then we'll be moving on to history, which we'll talk about Egyptian, Minoan, and early sort of early, probably dating back to cave paintings and architecture in the ancient Egypt and even before that.
Yeah, and one more comment on the stairs too. It's Inigo Jones did a beautiful stair called the Tulip Stair in the Queen's House in London, actually on Greenwich.
Oh, it's called, what is the name of it?
The Tulip Stair in the Queen's House in London.
I don't think I've ever seen it, but I'm dying to, it sounds wonderful too. Oh yeah, well this is neoclassical, so yeah, that would make sense. Wow. This is the one you're talking about, right? Well, that couldn't be the original. Is that the original handrail? Oh my goodness. Well, let's look at this for a minute. So let me look at, there's an interesting story about the way these, can you guys see this on the screen? Hold on a minute. Okay, can you guys see the tulip stair?
Yes.
Okay. Now the way this is done is that, and we have a good 10 minutes or 5 minutes. I was going to show you on my screen is that, let's take a look at the structure of that circus. There's an interesting story about Quinlan Terry's when he designed Lynn Muse's residence there on Preston Road. The large Palladian building is that the way these stairs are done is you can structurally do that without steel or what's called a stringer. In other words, what happens is, if you can see my drawing table for a minute, and I'm not good at drawing spiral stairs, but let's take a look at, I'm just going to draw a cross section of each one of these stairs. And Lizzie, can you see this?
Yes. Yes, it's a little small, but I think that people could perhaps pin your screen if they need to see it a bit bigger.
Okay, well, the section of this is technically what's called a cantilever in part. Here's the wall thickness. Here's the masonry. Here's the tread that comes out. So what happens is, once this meets the ground, the way the stairs structurally work is that, well, this is not the best, right? Is that you can cantilever out the stairs without what's called a metal or steel stringer, because structurally, the stairs are starting from one tread at the base, and then they build upon each tread that rests on the first step on the floor, number one. Then the stairs continually build on the one before that. So the structure is, it meets the ground primarily, and then of course it is tucked back into the wall. What I'm saying is, when Quinlan Terry, did the drawings for this and submitted to the city of Dallas or Holland Park, that they would not allow him to do this without a piece of steel, because they would consider that to be structurally unstable. But he's saying that this is how Renaissance architects have been doing this since the 1500s. You're telling me that I need a piece of steel when you can structurally do this? He actually, I think, went to the city and tried to prove that you could do, I might be wrong about this, you can do stairs without that extra layer. And so it's a little bit disheartening that someone as prestigious as the Queen's architect, Quinlan Terry, comes over to Highland Park and can't even do the staircase they've been doing for centuries. And so when you show me the staircase, I thought, wow, now this is how it's truly supposed to be done without a steel stringer, because you can structurally do that. But in Texas, in the building codes, you can't do that. But I'm glad you brought that staircase up. Look how beautiful that thing is, with just the treads just hanging out there. Hopefully that sketch I did made sense, but I think they actually made him put either a steel or a wall underneath that, but it's ridiculous. You don't need that for structural reasons.
Jay, have you seen the staircases that are coming out of Chesney's, New York, like this? They have a steel post-tension cable that runs up internally that they tighten up.
Right.
These things together, and they're just absolutely incredible.
I haven't seen that, but you really don't need that. You don't need that. I mean, for lateral support, I'm sure, but I think you can do that without those cables. But those are beautiful. Yeah. I mean, the staircase will hold up without the hand drill or without any sort of, because you don't structurally need the hand drill. Look how extraordinary that stair would be. But yeah, I'm glad I haven't seen those yet. But
well, the Chesney's ones completely float in air. They're not even attached to exterior walls.
Oh, okay. Well, in that case, it's called Chastity Stairs?
Chesney. It's the company, Chesney's.
Oh, okay.
Out of New York. They do fireplace mantles, and
wow.
they've got this new staircase system that they actually came over. ICAA had them over at SMU and gave a lecture and had a little model. It was freaky cool.
Well, how exciting. I don't think I've seen those, but that is neat. Yeah, I mean, look at how thin that staircase is. So now the tulip stair is in the banqueting house by Inigo Jones, or is that somebody was asking me that? Okay, well, anyway. If you go to the Museum in Dallas at University at the SMU, I think that there is a stair done like this, but I think that there has to be, I think the city made them put a piece of steel in that for support, but if it's done properly like the Renaissance architects did, you don't really need that structure. Yeah, I wasn't expecting the whole lecture to be focused on stairs, but they're pretty exciting zones in the world of architecture. Liz, it looks like we have more than 12 students. That's great.
Yes, we had about 20 today.
Oh, good. Okay. And so are there any other questions or?
No other ones in the chat here.
Okay. Well, it is 1 o'clock. I hope you enjoyed the lecture. Again, I'm sure you've probably seen some of these terms in your history or architecture class. Okay, so I will see everybody next Tuesday then.
Great, sounds good. Thank you, Jay.
All right, thanks, Lindsay.